These are solutions to one of the practice gateway exams that are posted online. The sections covered are the ones listed up here, except not these. We're just kidding about those. I guess those will be on here at some future time. Those are not covered on this gateway exam. So one of the main things on this exam is to be careful that you are doing what the problem says. So, for example, factor means to rewrite the expression as a product. Doesn't mean to do anything with it. We factor in order to solve equations. We also factor in order to simplify, especially rational expressions. So we factor for a bunch of different reasons. So factoring in itself is a skill that we want you to know how to do. These two problems say solve. So solving an equation means to find the numbers that make the equation true. So your answer to a solve question should be numbers that can go in for the variables, and your solution to a problem that says factor or simplify is just an algebraic expression that's equivalent to the one that's given in whatever way that you're asked to do it. So so in the first one here, we're factoring. So we need a product. We need to find two numbers who have a product of negative 30 and a sum of negative 1, and so you can go through the different factor pairs of negative 30, 1 times negative 30, 2 times negative 15, and so on. And what you'll end up with is the two numbers that will do that are negative 6 and 5. So that's your factor pair, and so therefore this thing factors as x minus 6 times x plus 5. So we call that the factor pair that we need to be able to do to factor something. Don't forget that it's easy, especially if they're nice whole numbers, to check this using FOIL. The more you check them, the better intuition you'll have for knowing if your answer is right or not. So check them explicitly using FOIL. It should only take a second, especially if the numbers are nice. In number 2, when we want to solve a quadratic, we want to make sure, first of all, that there's a 0 on the left side. On the right side. There is, so that's good. And then we factor the left side. So in this case, the left-hand side factors as t minus 1 times t plus 1. Don't forget that when there is no linear term, so there's no t term here, that means that the coefficient of that term is 0. So if we use the same factor protocol we used before, we would say we need two numbers that multiply together to be negative 1 and that add up to 0. When you do have that middle term of 0, adding up to 0 means that the two numbers in your factor pair have to be opposite in sign but the same magnitude. And so that's a big clue. So you know that in this case, the two numbers that are going to multiply together to be minus 1 would just be minus 1 and plus 1. So but our question is to solve, not just to factor. And so we say therefore that means that either the first factor is 0 or the second factor is 0. That's the whole point. And then those are both linear equations. Those are easy to solve. So that would mean t equals 1. That would mean t equals negative 1. So those are my two answers. When we have multiple answers, we often as a solution set, but that's not super important. But the main thing is that the answer there are not things with t's in. It's not the factorized form. It's the actual numbers that make the equation true. And again, since these are nice numbers, why not check? Right? Checking would mean putting those numbers back into the original equation and just seeing if they make the equation true. That would be a really good thing to do, especially if the numbers are nice and small. Okay, so in number 3, we do not already have the equation written out as something equals 0, and so I'm going to first rewrite this, and I'm going to rewrite it doing two things. First thing, I'm going to multiply out the left side, so I know what I'm looking at, and I'm going to subtract 40 from both sides. So this is the same thing. This is just a rewrite of that equation where I've multiplied out the left side and then subtracted 40 from both sides. Now this does look like equation equal to 0, and so now I can try factoring the left-hand side. My factor pair in this problem would have to multiply together to be negative 40 and sum to be 3. And so if you run through the factors of negative 40, you'll come up with a factor pair of 8 and negative 5. 8 and negative 5 have a product of negative 40 and a sum of 3. And so this factors as x plus 8 times x minus 5. And again, at that point, we can check that with FOIL. Right? Anytime we factor something, we can check using FOIL. But again, that's not the answer to the question. The answer to the question is, what numbers can you put in for x to make this true? Well, if x plus 8 times x minus 5 is 0, that means x plus 8 is 0, or x minus 5 is 0. And so that means x would be negative 8, or x will be 5. So my solution set here is negative 8 and 5. And again, don't be afraid to check. Checking would mean putting those back into the original, like all the way back into the original, to make sure you didn't make any mistakes. Certainly the 5 is easy to check, right? If you put 5 in for x here, then you get 5 times 8 equals 40, which is true. If you put negative 8 in for x, you get negative 8 times negative 5 equals 40, which is true. So it's easy to check that those are both correct. In number 4, we are trying to solve the equation f of x equals g of x. We know that if we were looking at graphs of f of x and g of x, then this would indicate where the two graphs intersect each other. But there are no graphs here. We actually have algebraic formulas, and so we can find these by just literally, instead of f of x, write down what f of x is equal to, and instead of g of x, write down what g of x is equal to. So this formula, f of x equals g of x, is exactly the same thing as saying this thing equals this thing. And so I'm trying to solve that. Right? Again, the word solve there means I need to find numbers that will make that true. So our procedure is to first make the equation look like something equals 0. If we try, excuse me, if we try factoring this, this could take some time to try to factor because the numbers are pretty big, and we would need a product of negative 72, and 72 has lots of factors. So let me just, for the interest of time in this video, let me just assume that I've given that at least like 2 or 3 minutes of effort, and I haven't not been able to find a factorization. And you may want to just decide that if there's too many factor pairs to consider, you'll just go right to the quadratic formula. But either way, eventually we'll end up with the quadratic formula in this case. So the quadratic formula says x is giant factor fraction bar minus b. So that's minus b. Remember, when they're in this order, this is a, this is b, and this is c. So I'm applying the quadratic formula with a equals 8, b equals 7, c equals negative 9. So negative 7 plus or minus square root of b squared, which is 49, minus 4 times a times c. So that's what the numerator of the quadratic formula looks like, and then it's divided by 2a. So here a is 8, so divided by 16. We do want exact answers to these, so don't put this entire thing in your calculator. The only thing that should go in your calculator is this part that's under the square root. Not the square root part, just the part that's under here. If you do 49 minus 4 times 8 times minus 9, you get, let me see, you get 337. So, so this is negative 7 plus or minus the square root of 337. So the only place I'm using my calculator is to figure out what this giant number is under here. And that's only because the numbers are big, right? If it was just small numbers or had zeros in it, I could probably do that over 16. So those are your two solutions. It's worth checking, like take the square root of 337 on your calculator if you're not sure, but that definitely is not a perfect square. There's nothing nice about that. In the MyLabs Plus problems, they will want you to try to write that in a simplified form. This one can't be. There's nothing. There's not going to be anything that's going to cancel out with a 16 that you're going to be able to bring out of that thing. But for the purposes of these gateways, you don't have to simplify it. Just that could be your answer. So remember, that's two different values of x. They're not nice numbers. You can tell because the square root of 337 is not nice. But there are two different solutions to this. So if we saw a graph of these two curves, one's a parabola, one's a straight line, and there's 2 points of intersection of those two curves. All right. Number 5 is really the same kind of problem, just not with the f of x, g of x notation. We're just trying to solve this. And so again, my first step is to bring everything over to the left-hand side. So I'm subtracting x from both sides and subtracting 57 from both sides. And so my equation is equivalent to x squared minus x minus 30 equals 0. And I have to have that equal 0 for my factorization to result in a solution. So I'm going to try factoring this thing up here. Is this the same one on the other page? It might be. I think it's exactly the same one on the first page. But they're random, so you don't know that. But again, we don't have to sum up from scratch. I need a product of negative 30 and a sum of negative 1. So negative 6 and 5 will do that. But this is a solved problem. It's not just factoring. So I conclude that x minus 6 is 0 or x plus 5 is 0. And so that means that either this equation being 0, or this equation being true means that x is 6, and this equation being true means that x is negative 5. So my solution set is 6 and negative 5. And again, is that easy to check? It's not hard to have a calculator. When you put in 6 into the original, this is 36 plus 27. So use your calculator, that's, 63. And then this side, 6 plus 57 is 63. So certainly putting 6 in on both sides works fine. And if you check, putting negative 5 in on both sides works fine. So I'm 100% sure that's right. Number 6, solve the following equation. This is already written as equal to 0, so I don't have to worry about that. I can spend some time trying to factor it like I did before, but just like before, I see that I need a product of negative 72 and a sum of negative 11. So remember, what we're looking for in this case is basically you're looking for your outer and inner terms of FOIL. So we know the outer and inner terms of FOIL are going to have to add up to negative 11 and sum to, add up to negative 11 and multiply to negative 72. So you can jump through the hoops to look for those, but again, in the interest of time, I will tell you that there isn't one. You're not going to find it, and so again, we resort to the quadratic formula. Here the quadratic formula is applied when a equals 8, b equals negative 11, and c equals negative 9. And so it'll say x is minus b, so that's the opposite of b, plus or minus. Remember, this is one giant fraction bar, goes all the way across. Under the square root sign is b squared, which is 121, minus 4 times a times c, all under the square root sign, and divided by 2a. So again, that's 16. So once again, the only thing I should be doing on a calculator is figuring out what this number is, and then verifying that it is or isn't a perfect square. So it looks like it's 409, I think, if I'm reading my calculator right. So 11 plus or minus the square root of 409 over 16. It's at least worth seeing if 409 is a perfect square, like take the square root of it and make sure it's not a whole number. If it was a whole number, then you would have two nice answers. So it's definitely worth checking that. But once you use the quadratic formula, that's about as far as you want to go. If the square root of 409 is not nice, which it's not, then that's really your two answers. So x could be either one of those two things.